We have two challenges here in angular kinematics. The first one is about a game like Need for Speed, in which a wheel is making 120 rotations per minute. What is the speed of the car? So we are looking for the speed of the car if the wheel is 100 pixels high. So the height of the wheel, in case of a wheel, the height is the diameter. So diameter of this wheel is 100 pixels. If we have a wheel, diameter is this size from the top to the bottom, and most formulas we are going to use is only about this part, which is radius, which is half of the diameter. So our radius in this case is 50 pixels. So the question is about the velocity, linear velocity, which is also called in angular physics to differentiate between angular velocity and linear velocity. This linear velocity is usually called tangential velocity. Let's have a look at the formulas that we have. These are formulas for the rotational kinematics. Tangential velocity is here. Vt, tangential velocity, equals omega r. Vt equals omega r. Instead of omega, we have something that says 120 rotations per minute. There are two ways of finding what we are looking for from this. Rotation per minute is highly not any kind of measurement of unit, measurement unit that we would really like. But what we can do with these 120 rotations per minute? First of all, 120 rotations per minute is in fact just 2 rotations per second. A rotation per second is something that's called frequency. So our frequency is 2 rotations per second. Rotation per second is in physics a special unit of the measurement called hertz. So the frequency, it's not angular frequency, it's just frequency. Frequency of this wheel is 2 hertz or 2 rotations per second. So that's one way of converting this value of rotations per minute. The other one is if you just notice that 120 rotations is 120 full rotation angles. Full rotation angles is 2 pi radians. So it's 120 multiplied by 2 pi rotations, radians. Now these are radians per 60 seconds. Minute is 60 seconds. Number of radians taken over time, that's the definition of the angular velocity. So we can find from this 120 our angular velocity as 240 pi over 60. 240 over 60, it is 4 pi. So we actually can directly from this data we can find angular velocity as 4 pi and the unit is radian per second. Okay, whichever way you choose, either finding rotations per minute and then rotation per second, which is frequency, or calculating the omega knowing the angular measurement of 120 full rotations, and each rotation is 2 pi radians, we will end up, as you will see in a few moments, with the same value. Omega is something we really need, because if you know omega and you know radius, you can calculate the tangential velocity, the thing we are asked for in this exercise. What if you just know the frequency and imagine that we haven't done this calculation? Simply we know that the frequency of this wheel is 2 Hz. From the definitional formula for frequency, which is here, please note that this is exactly the same formula that you can use for springs and pendula. So it's this formula is basically repeated here, but in rotational kinematics it's exactly the same thing. Frequency is omega over 2 pi. Frequency equals omega over 2 pi. So omega is 2f pi, or 2 pi f. 2 pi is 6 point, let's leave it with the pi. It's 2 times our frequency is 2 times 2 pi, so it's 4 pi. We actually have the same result as from the other way of calculating. Whichever way, we will end up with the information that our omega is 4 pi, and now we can easily find the tangential velocity, which is omega r. Omega is 4 pi times radius 50, it's 200 pi, and 200 pi, it's around 628, and the unit is, I have to move my, maybe I will rewrite it here, 628 pixels per second. That's the desired motion, velocity with which this car should move, so that to obtain the frequency of 2 full rotations per second, or 120 rotations per minute. We have another similar exercise here in the same game, same wheel size, so we still have radius of 50 pixels. You want to maintain the car speed. You now know that the car speed is the tangential velocity of 200 pixels per second. I had a very similar case quite recently when I created for you a game about skulls and ropes, and I also had a small velocity of the skull. In my case it was 100 pixels per second, and the radius of my skull was significantly lower. I think it was about 12 pixels. In both ways the calculation would be exactly the same. So these are two sets of data for two different exercises, two different tasks. The question is about what should be angular velocity. So the question is about omega, and we once again are going to use the same formula for the tangential velocity. Tangential velocity is omega r. If it is, then omega equals Vt over r. So for this exercise, Vt was 200 pixels per second, and r was 50 pixels per second. 200 over 50, it's 4 pixels per second, divided by pixels, it's per second. What per second? Radians, of course. Okay, so we have 4 radians per second. In the GFC library, the omega should be provided in degrees per second. So additional calculation omega, which is 4 radians per second. How many degrees it is? 1 radian, maybe not 1 radian. a full rotation angle is 360 degrees or 2 pi radians. That's something that you just have to know. Perhaps more useful is to know that 180 degrees is 1 pi radians. Therefore, we have these two numbers which are always used in the two-way conversion between radians and degrees. What we should do here, our omega is 4. Well, you have to multiply by one of these numbers and divide by the other. Radian is quite a lot. Radian is more than 50 degrees. So a small number of radians will be a high number of degrees. And this is another rule of thumb. If you know that to find number of degrees, we have to multiply by a big number and divide by a small number. Of course, we will multiply by 180 and divide by pi. You can use calculator for this calculation, but it will be 229 degrees per second, and that's the other form of the answer to this question. During the in-class test, you don't have to calculate degrees from radians. I will be absolutely happy to get the answer as 4 radians per second, but working on your coursework, working with any piece of software, you should be quite confident while converting between radians and degrees. One more angular kinematics task. In a game like Wii Sports, an athlete throws a hammer. Just before throwing, the hammer performs circular motion with radius of 2 meters. In 1 second, the athlete makes exactly 2 full rotations. Our rotation per second is frequency. So our frequency F equals 2 rotations per second. Rotation per second is also known as hertz. So it's 2 hertz frequency. What is the initial speed of the hammer? Here is our formula sheet. We are going to use once again the same two formulas. So we have frequency here and tangential velocity here. Tangential velocity is omega r, and we also know that frequency is omega over 2 pi. From this formula we can find omega. Omega is 2 pi f, and we can immediately calculate this. It's 2 pi times f, 2 hertz, so it's 4 pi, as in the previous exercise, I think. Having omega, we can very easily find the tangential velocity, the velocity of the hammer, which is Vt equals omega r, so it's 4 pi times r is 2 meters, so it's 8 pi. It is about 25.12 meters per second. That's the answer for this exercise. Thank you.